Hello everyone, my name is Vishwas and my roll number is 2201CS78. Today I'll demonstrate lab 1 assignment which is Symmetric key encryption secure file transfer system where we'll be using AES-256 encryption in CBC mode, RSA 2048 for secure key exchange, HMAC SHA-256 for integrity verification, PBKDF2 for password protected key storage. This is my folder where I have generate keys PY for RSA key generation and sender encrypt PY for file encryption, receiver decrypt for file decryption, and document PDF, which is our sample file. So I'll explain the code. This is our RSA key generation. So this file generates the RSA key pair. First, it generates the 2048-bit RSA private key, and then the corresponding public key is extracted. The private key is saved as in this name in PEM file, and the public key is saved as in this name PEM file. The public key will be used by the sender to encrypt the AES session key, and the private key will be used by the receiver to decrypt the AES session key. Now I'll explain the sender encryption code. So first we'll import all the required stuff, and then and then the receiver's public RSA key is loaded from the receiver underscore pub pm file. Then a random 256 bit AES key is generated, and then a random 128 bit IV is also generated, and the input file is read in binary mode. Since AES is a block cipher, the file is padded using the PKCS7 padding, and then the file is then encrypted using the AES 256 in CBC mode with the AES key and IV. After encryption and HMAC using SHA-256 is computed over the IV and ciphertext. This HMAC ensures integrity and authentication, and the encrypted file is stored as IV plus ciphertext plus HMAC in a file named document.pdf.enc. And then the AES key itself is encrypted using the receiver's RSA public key with the OEAP padding. So this ensures only the receiver can retrieve the AES key. Now we have the password protected key vault. Now the AES key store is stored in password protected vault, and then a random salt is generated, and then PBKDF2 is applied using the SHA-256 with 1 lakh iterations and the user password. So this derives a strong vault encryption key, and the RSA encrypted AES key is then encrypted again using the AES and the derived PB KDF2 key. So this encrypted vault is saved as key vault.py. So this ensures the AES key is protected by RSA and also protected by a user password. Now I'll explain the receiver side, which is key recovery. First, we'll import all the required stuff, and then the receiver's RSA private key is loaded from the receiver underscore priv.pm file, and the password protected vault file is read, and the salt and the encrypted vault data are extracted from the file, and then pbkd is applied again using the same password, salt, and the iteration count. So this recreates the same vault decryption key, and this key is used to decrypt the RSA encrypted EAS key, and then the RS private key is used to recover the original EAS key. Now the encrypted file document .pdf enc is loaded, and then the IV ciphertext and HMC are extracted from the file. And before decryption, the HMAC is verified using the EAS key. If HMAC verification fails, the program stops immediately. So this prevents tampered data from being decrypted. And if verification succeeds, the cipher text is decrypted using AES-256 in CBSE mode. And then the PKCS7 padding is removed. And the original file is restored as document underscore decrypted.pdf. Now let's run our code. To run our code, we have to go to our terminal, and then first type Python generate keys.py, enter. As you can see, RSA key pair is generated, We have our receiver private key and we have our public key. And then now we will type sender encrypt.py. Here's what happens internally. A random 256-bit AES key is generated and a random IV is generated. The file is encrypted using AES 256 EBC and HMAC SHA 256 is computed for integrity. The AES key is encrypted using RSA 2048 and the encrypted AES key is stored in a password protected vault using PBKF. So the output shows the generated IV and the computed HMAC and the encrypted file name and the password protected key vault file. So the new files created are document.pdf.enc and the key vault.bin. Now we'll type our next one, which is receiver decrypt. So as you can see, we had our key exchange also before this. Encrypted AES key has been sent securely and the public key has been sent to receiver. In receiver side, what happened is in this file, what happens is the AES key is recovered from the PBKDF2 protected vault, and the AES key is decrypted using the RSA private key. The HMAC is verified to ensure integrity, and the file is decrypted using AES256 EBC. And the output confirms AES key recovered successfully, and HMAC verification is passed, and the file is decrypted successfully. So to summarize it, so the system follows the encrypt then MAC principle. This provides confidentiality, HMAC provides integrity and authentication, RSA provides secure key exchange, and KDF2 provides password-based key protection. Together, this ensures that only the intended receiver can decrypt the file, any tampering is detected, and the encryption key is securely stored. So, this is successfully completed. Thank you.